Let me get started by saying thank you for this opportunity to make this presentation. It's very much appreciated. My name is Jeff Walling. I'm the author of the API Toolbox, and I want to just take this time to present an overview of the cloud version of the API Toolbox Enterprise Plus. I would say the most outstanding feature of the API Toolbox is that it provides virtually every technical industry reference and assorted tool that a reliability engineer and or API inspector would need to do their job without hardly ever breaking open a code book. You'll find that most engineers or chief inspectors, when on a project, will have 4 or 5 code books opened and placed strategically about them, as many times as codes reference other codes. That's a typical scene there. Looking up NDE inspection criteria, flange dimensions, material specs, material stress values, calculating horizontal tank bending moments, and such. This program will reduce that effort by 95%. You'll hardly ever have to open another code book. It's a real great tool for the, especially the engineer and the chief inspector. All right, these references, they come in several forms within the program, such as code bytes. Okay, code bytes are found in these tabulated windows. Okay. In all the modules, the above ground storage tank module, this which is API 653 AST, the pressure vessel module, which is the API 510 PV inspection, and the piping module, the API 570 pipe inspection. All right, and that proved that basically when you come in here, you'll have these tabulated windows, and they are divided up into, well, for the API 653 module, they're divided up into different components, such as the tank bottoms, shell courses, and so on, and other areas, pressure relief, foundation, containment. Here it is where you'll find excerpts from the codes, including specific values, tolerances, tables, NDE acceptance criteria for the various NDE examinations, and paragraphical references to where the excerpts came from in the design codes or the inspection codes. And as you can see, once you click on a tab here, it comes to this tabulated window, and it's broken up in subpages. The first one that you see will be the design of tanks, and then it also is broken down to inspection of tanks and repair of shell plates. All right, this is specific to the shell courses. You have fixed roofs, tank bottoms, floating roofs, shell nozzles, and so forth. And each one of them starts out with a reference to what code, the latest code that this was based on. And it has code bytes, just about anything that an engineer or inspector look at the predominant things that they have issues with, that they need to have information. Minimum design thickness, all right, for tanks less than 50, for tanks less than 120. There is your code reference. So it's the API 650 code, paragraph 5.6. Minimum design width of shell plates, all right, weld spacing. So these are the code bytes that you'll find here. That it would be your first step to finding answers when you're trying to do evaluations. You also, again, have your inspection of tank shells based on API 653 and whatever this latest edition is referenced. And again, you have your code bytes. And if you want a more, these are generalized regulations from the codes, but if you want to know the specific, you just go straight to the code and look it up, and it gives you the paragraph. Same thing for the repairs. Okay, so that's your first reference form, these little code bytes. The program has the most commonly referenced industrial standards at the click of a button. Up here, if you go to engineering data, it's broken up into 4 different areas. One is your above ground storage tank calculations, your pressure vessel calculations. These are just individual calculations of the different components that make up a pressure vessel. Your material library, your pipe calculations. Okay, now in the material library, we have material specs, post-well heat treating, evaluations, process specs, product data, engineering calculations, which is just basic fundamental calculations, square areas, cubic areas, you know, a quick way of doing conversions and this, and we'll look at all this in a minute. Pipe standards. So you have all these references here. Rather than trying to dig them up in some library somewhere, you have them at the click of a button. All right, so let's look at the material specs. All right, in here you have some of the most common material that we use in the industry. Everything from your chromes, your bolting materials, your carbon steels, your stainless steels, and then your exotic metals. All right, this will have 99% of what you're looking for. There will be that 1% that may not be listed here, but you can list it here by adding it here once you find the specifications for that. If you click, let's click on a very common material here, some carbon steel, which is your most common material in the industry. When you click in here, you'll see that within each page is data or information related to that material that was pulled in from several different resources, saving the user time from having to find and look up that information up in the various codes. This is where you have, you will find your basic stress values, your tensile stress, your yield stress, your chemical composition, again, from a different, these are all from different sources, so you have them all right here. You don't have to go look them up. You have your stress values at temperature before the safety value change in 98. There's before 9, this is the 4 times safety factor. This is your 3.5 times safety factor at temperature. And ASME notes, external charge, your USN numbers, all kinds of good data here. Here's additional material physical data. Here's your velocity for that material, density, galvanic series and such. Down here some additional information. This is good information if you're part of a team that's evaluating a fire on the plant or whatever, where they set up their heat zones and such, and it gives you your different heat ranges for stress relieving, transformation range, your carburization range, annealing range. It also gives you the 3 main hardness testing methods, your Vernal hardness testing, your Rockwell, and your NOP. Okay, it gives you your high and your low, so when you're testing this particular material, where your ranges should fall. Okay, down below you have additional information, welding rods, for instance. You could select from SMAW or GTAW, GMAW type welding methods, and then once you come here, you can select a material, let's say a 316L material, and you want to weld it to a carbon steel. There is your particular weld rod. You also have alternate weld rods that you can find. And then if you want to know more about that weld rod, you just look it up in here. Whichever one that was 16 actually. And it gives you more data on that. There's your A numbers, your F numbers, your AWS class, your UNS numbers, your chemical composition, and your tensile strength. And then a note from ASME where this is most commonly used. Okay, also have other little guidelines and notes down here. Very handy in developing procedures, weld procedures and such, and checking their procedures. Okay, you have to go back to that material. You have modulus elasticity, thermal coefficient, minimum design metal temperature evaluations, post-weld heat treatment. It's all right here, and this comes from several 8, 9, 10 different sources, and you have it all in one page here at the click of a button. Okay. The next thing we have here in the engineering data is pipe standards. So pipe standards you click on that and it comes up with a pop-up, and you have your class ratings from 150 to 1,500 pound flange sizes and your well neck, long well neck dimensions. All right, we'll just click in here. Again, another pop-up. If you want to know your flange ratings at pressures at temperatures, you pick what group number is, what material and group number it is. The most common, of course, is carbon steel 1-1. And there's your maximum allowable working pressures, 285 up to 100 degrees. At 650, your maximum allowable working pressure is 125. So it's that quick and simple. You have also your well neck flanges and your long well neck flanges. You select the size, let's say 10-inch, and there's all your variable for each of these dimensions here. If you want to know what the definition is for any variable, there you go. Okay, that's really convenient. It's a lot of data, a lot of information at the touch of a, this will reduce you looking up data in different codes and trying to figure out what code to look for. It's all right here. Carbon steel pipe sizes, you pick a size, and then you get your data, your schedules, your OD and such. All right, it also has it for stainless steel, for aluminum, your practical T-mins used by this program, stress tables for piping, bolting, insulation, valve weights, pipe specs, flange weights, gaskets. So this is a lot of data, a lot of standard, industry standard information. You also have here under your engineering data, your process specs, when you're evaluating system, doing an inspection, and you review some of the process, some of the degradation corrodants within the process. You can look it up here. Hydrofluoric acid, it gives you the material types, the best use for that, the construction references, your heat treatment references, your NDE references. It shows you where you would find what units you would find that in, mostly in the process, the corrodants, the degradation to expect, and treatments for that, and then some other notes down here. So it's really a handy tool to doing evaluations and determining corrosion rates and such. This will give you that in a lot of cases. One of the typical ones, it would be your naphthic acids. Let's see here. There's your nap acids, and it gives you a bunch of scenarios where different piping can be used and what to expect for corrosion rates. It gives you, we also have a way, nap acid re-rating. So if you're going to change up material within a system that has nap acid in it and you have a history and you know corrosion rates, you could actually determine how the new material will affect the corrosion rates. So you just put in previous information that you have already on record, your history, and then what your new temperatures will be, and it'll give you a new corrosion rate. So pretty handy, and it's, you got a lot of the acid charts and for like your sulfuric acid corrosion rates. Well, this is missing its chart. We'll have to get that fixed. Let's see here. Yeah, here you go. There's your Gomer charts, economy curves here for your H2S corrosion and such. So it's very exhaustive in information in industry process, industry specs. Okay, you have engineering calculations here. This is just a real quick. You want to know the volume of something. You want to know how much gallons or cubic feet. You just come here, pay attention to your units, put in the variables, and it'll give you cubic feet, gallons, barrels, surface area, and such. You also have a conversion charts here for lengths, areas, just your basic conversions within that you need in the industry. Very handy tool. Okay. Then you have also the component calculation. So just about every component calculation that you would need as an reliability engineer or inspector. These are just independent calculations. And if you're just concerned about, let's say, shell settlement, then you would select that and just put in your variables, and you won't have to tie it into anything else, but you may have to do some extraneous calcs for some of these other components that may be affecting that calc, but you have it right here at the touch of a button. Horizontal tank evaluations, cell settlement. The cell settlement that we have here is set up for refined readings. So if you go out in your minimum amount of readings is 8 points. You could double that and refine it, and then if the first settlement evaluation with the cosine curve is not applicable because of your R square, then you have available to you the code gives you the next step, okay, where this evaluation would no longer be applicable if your R square is less than 0.9. You have the option of going to the next step, which no other program out there on the market has this. So it's a very valuable calculation here. It takes a little bit to run through the iterations. This was a large tank. It has 36 points. It takes a few seconds to run through the iteration to find the best fit, to be able to compare your R square to the best fit, which is what it's doing here now. And all this is relative to your connection and your speed over the net. And it normally goes a little faster than that. I think my computer's running a little slow today. Okay. There you go. So in this case, if it is less than 0.9, it comes up in the red. You know immediately that this is not the calculation. It does not fit well with the cosine curve, as you can see. So the thing is, you have to input your X in the peak high points according to the code. And if you look this up in API 653 Appendix B, you'll get a better understanding of that. And then you just simply go to the next step, and then it automatically does the right evaluation for you here. And I always recommend you take double sets. If your minimum is 8 points, do 16. It refines it, and you have a much better evaluation, much more refined evaluation. Okay. All right, and then the next thing you have is all your modules, your API 653, your API 510 modules. When you come in here, and again, we've seen earlier where you have your code bytes, but again, down below here, you have repair specs. You can develop, I have a general, but then I have some specific that are common to the industry that we do a lot: nozzle installations, repad installations, nozzle removals, shell inserts, and such. You have that available. Inspection forms. You come in here, click which forms you want, name a set if you want, so you can keep some preliminary sets in here. You select them whenever you need them, print them out. Okay, these are all the relative data forms for collecting information in the field. Hydrostatic testing, if you're going to do hydro testing, and the report builder, which is the heart of this program for inspectors. You come into a base page, and you have plenty of options here of starting a new report, copying a report, or downloading templates that you can put into an iPad or notebook. You take it out to the field with you, input the data, come in, upload it to the program. And man, that reduces your time writing reports incredibly. Once you get it up in here, always remember to do your saving. And you got your appendices to do that will come in with your UT data, your calculations, places to put your drawings, checklists, photos, other information, and your NDE records. And then you have the write-up, which is here that you input your findings, and then you also put in your recommendations right next to it. And then you have your executive summary down here. Makes a very nice report, and it reduces, it's got everything you need, all the elements that are required by the industry and by most clients. It will reduce kickbacks on your reports by, again, probably 95%. Okay, as we showed earlier, you have all the metallurgical evaluations and information that we showed you earlier. When you go into the material library, you got post-well heat treating, product data, that's for like gasoline and the specific gravity of gasoline, and your boiling points and your flash points and all that. Okay, and it's got some of the most common products in the industry. So pretty much that is what we have here in the toolbox. Kind of was just a real quick overview of the different modules and the different capacities that it has. And one other module that is coming to the to be added within the next couple weeks is our asset management database, and I'll show you it in the Access version, and it's pretty much like your U-pipe or your PCMS programs, except that this does not receive UT data. It does not track the UT data, but it does track inspections per each individual piece of equipment. So you come in here to this base page, and you have the components, your assets, your process vessels, your tanks, your process piping, and related components or related assets to that. Here you go, when you click on whatever asset you're concerned with, it takes you to this tier 1 level. On this level you have a list that is per unit. So you select your unit, say it's a reformer or the boiler house or fuel gas unit, whatever. You pick that unit, and then it will list all the pieces of equipment by vessel type under that unit. Okay, so if you have 5 or 6 units within the plant, there you go. It displays at this level your vessel ID, the vessel description, the type, some dimensions, and then your next inspections. I use this as an example here. This one's is filled in. If you are overdue, it will show up in red. If any of your inspections, so your UT and your externals are overdue here. Looks like you're still good on your internals. It also has an RBI ranking, and it has color-coded for, critical is red, green is the least critical, and yellow is moderate. And then a reference to the P&ID. So this is a real quick way of determining some of the information that most folks are looking for. They want a P&ID reference, or they want to know some dimensions. And then up here you have your queries for the next inspections, and I have them set up in external and internal. And say, let's say I want to query for the next year, the external inspections. There they are, and they just list them, and you have your units, you have when they were due, there's inspection frequency, and the next inspection. And along with that is the UT. The UT always comes up with the external and the internals. Okay. And then you have the same for internal inspections, and then unit vessel listing. So if you want to just list every one of these, and for some reason, you just click here, and it will list every one of these vessels here per unit. Okay, so now if you want to know more about that piece of equipment, you go to the next level, and this is where all the static data is kept for that piece of equipment. Up at the top, you have where you can enter action items from an inspection. You found some discrepancies. You want to plan on repairing them. This is where you can list it, and it will come up on a query from the front page with a priority setting. You also can store all your historical documents here, your design documents, your drawings and such, U1s, R1s. It can all be stored here in PDF format. This is where the results of your inspection go. You determine your frequencies, either based on RBI or based on maximum allowable in the codes or corrosion rate. Put that here, put the last inspection here, and then it automatically gives you your next inspection based on your frequencies. This is where you have all your data concerning that piece of equipment, sizes, and then related RVs. Here you can just select which this particular one has 2 RVs. I pick which RV I want, and then I can click on PSV here and go to that record. All right, and it shows me the inspection intervals for that, static data for that, any notes, and any stored documents for that. All right, and then down below for inspections, this goes hand in hand with the API Toolbox reporting modules. You go out to this vessel, you do an inspection on it, you're inspecting the whole entire vessels, the heads, the shells, the nozzles, you're determining corrosion rates within that report, and then it has your critical corrosion rates and remaining life become for each of the component that governs the next inspection frequency. So you would put the report in here, and then you would update your last inspections, change the frequency if it's warranted, and you're done. You don't have to input all your UT data in it, and the program does not track that. This is for, it's for any size plant, but it's especially good for small plants and medium-sized plants. It's not as much maintenance, and it does track your inspection intervals, your vessels, and your action items. Click here for your action items, gives you your action items, your priority for those. It tells you the item, the area, the work order, and a little real quick brief description of the issue. All right, so that was a quick run through of the program. I sure appreciate your time here. And this will conclude the overview presentation of the API Toolbox software. Please feel free to pursue